Okay, we're jumping straight into a new Unity URP project. Going to Package Management, Package Manager, and in here in the Unity registry, you'll download Cinemachine and TextMesh Pro. And then in the asset store, there's a free RPG animations pack by Double L that you'll download, and you'll find that in My Assets. Now we're going to go into scenes and rename our sample scene to something like Mechanics Testing Scene. Then we will go over here and create a new quad, which we'll call Ground. We'll rotate that 90 degrees, zero out the transform, and I'm going to delete this mesh collider and replace it with a box collider. You don't have to do this, but over time, if you add a bunch of things with mesh colliders, they're not very performant, and it's a quad, so there's no reason not to just use a box collider instead. And now let's create a new folder, and we'll call this Materials. And inside our Materials folder, we'll create a new material, which will be green, and we'll make it something a little grassy feeling. We're not going to get too in-depth here with our level design, but grayscale makes me want to die, so just a little bit of simple colors to make things easier to look at, I think, is very helpful in the beginning. Now we're going to go into the Double L folder and grab this armature prefab. We're going to just resize the ground here so that it doesn't look like he's standing on a little tiny square. And then we'll zero out this transform as well. Now let's unpack this prefab completely and rename it Player. I'm going to create a new folder called Prefabs, and inside there I'll make another folder called Player Prefabs, and I'll just drag the player into there. Okay, now this animator controller is not going to work, so let's create another new folder, which we will call Animators, and we'll make a new controller that we'll call Player Animator, and we'll just drag that into the player. And if you double click on that, you can open it up, and I'm going to drag it over here instead. Now create a new blend tree. We're going to name this Locomotion. Double click on that, and inside there, we're going to drag some animations. So inside our Double L folder, there's these one-hand style animations like idle, walk, run. We're going to add all of these to our blend tree. So first we'll do idle, then we'll do walk forward, then we will do run forward. Make sure you're using the ones that have F on the end. That means forward. And now if you hit play here and you start dragging this number around, you'll see we smoothly blend between idling, walking, and running, which is really cool. That's exactly what we want. We'll take this blend here and just rename it movement. So you can imagine 0 to 1 is our joystick not moved at all, or is it fully moved? And if it's fully moved, we should be sprinting. If you're on a keyboard, as soon as you press W, you're just going to be moving forward at full speed. Now I'm going to just start creating some of these things that we'll be using for testing in the future. So I'm going to make a little platform here, and I'm going to drag it out here, scale it up, move it around a bit. Going to duplicate that, create a wall, scale this a bunch so that we have a wall, move it out, rotate it. And again, just so everything's not exactly the same color, I'm going to go back into our materials folder, and I'm going to create a new material for this, which I will call Blue Grid. And I'm going to add this default checker map to it, and then just make it nice blue tint here. Drag that onto that, change the tiling, and then this looks all stretched because the Y and the Z are not the same. I'm going to set them both to 25. That looks a little bit better. And we'll go in. Yeah, there you go. Big wall. Exciting. Okay, now let's go back into our prefabs folder and create a new folder called Environmental Prefabs. We're going to drag any environmental stuff into there, so like our wall and our platform. And now let's create a ladder. We're going to use this in a later video, but just showing an example of how you can really create a lot of things with just Unity's built-in stuff here. Underneath the ladder parent, I'm going to create a cylinder, which we will make much smaller. We'll call this one the left side, and we'll scale up the Y. That's too big. Let's make it 2. Slide it over. Looks like negative 0.35 is okay. Duplicate that, call this one right side, and we'll put it over at positive 0.35 so that they're evenly spaced. Now I'm going to create another cylinder. I'm going to rotate this one on the x-axis. This will be a rung. We're going to scale it down, and we're going to have to scale the Y back up to, looks like about 0.35 should be perfect. and then we will just duplicate that and space them out. Now I'm going to kind of fast forward through making this ladder. Just skip ahead to where I've got a finished one. If you're having a hard time making a material that looks brown, pro tip, little color theory, go to orange and then darken it. That's going to be how you get the brown color. Now over here, I'm just going to make a little stairway leading up to the top of this thing. I'm going to fast forward through this because this is literally worse than watching paint dry. But you get the idea. Just some really simple level design type stuff, purely for the sake of being able to test our different mechanics, our different movement abilities, the ability to jump, the ability to climb ladders, all those kinds of things that we're eventually going to be adding here. Now I'm going to drag all of these under one parent, call that stairs, and drag that into our environmental prefabs. Voila! Let's hit play and see what happens. Our guy is just standing there. He's not moving because we haven't actually done anything to tell him how to move. So let's get back out of here and take care of that. We're going to go to our player here, and he needs a script. So we're going to create a new folder called scripts. And inside that folder, we will make a new script called player move. We're going to drag this onto our player prefab, if I can do that. Open it up and dive right into this. Delete the start and update methods. We're going to make a header called references. And underneath that, we're going to have a serialized field for our animator. And we'll have another serialized field for our transform camera transform. This is going to be important that we have a reference to our camera because if the camera rotates, we want to make sure that whatever you think is forward, the game still treats as a forward movement. If forward is always just based on the world's forward and you rotate your camera, you're going to push your joystick forward and see your character move to the left, for example. We don't want that. Now we're making another header here for input actions, and we're going to have a reference to our input action for moving. This should automatically add the using Unity engine.input system at the top. If it doesn't, make sure you put that in there. Otherwise, it's not going to work. You'll have a little red squiggly line, but it should do it automatically. And then we're going to make one more header for movement, serialized field. This one will have a range of 0 to 1, and this will be a float for our movement threshold. So this is like what we were doing inside the animator, dragging that 0 to 1 and seeing our character move. We'll serialize another field for a string. This will be our movement parameter, movement. Now this string needs to be exactly what you wrote inside the animator. We've serialized it so that you can tweak it in the editor. I'll show you later if you don't remember what that's supposed to sync up to, and we'll make sure that it's working properly. We'll have another serialized field. This one is a float as well for animator damp time, which we'll initialize at 0.1f. We'll make another header for rotation. We're going to have a serialized field, another float, rotation smooth time, and we'll set that to 0.05f. Then we'll have a private int for movement parameter hash and another private float for rotation velocity. Now let's make our awake method. We're going to say if our animator is null, then our animator equals getComponentAnimator. Basically, just if you forgot to drag the animator in, we're going to find it anyway. We're also going to say that if our camera.main is not null, then our camera transform equals our camera.main.transform. Once again, if you just forget to drag it in, we will simply find it. Then we're going to say movement parameter hash equals animator.string2hash movement parameter. Now on enable, we need to make sure our move action is set up. So we're going to say if move action does not equal null, move action.action.enable. Don't put disable like I just did. And then you can copy and paste this and just change everywhere it says enable to disable. This will set it up and turn it off all properly, make sure there's no leaks and stuff. Now we're going to make our update method. We'll say vector2 move input equals move action does not equal null, question mark, move action dot action dot read value vector2 colon vector2 dot 0. And we'll pop back down here and make a float, which will be movement value equals get movement value. We're going to take as an argument for that method the move input. We'll actually make that method in a bit here. Then we'll say animator.setFloat movement parameter hash, comma, movement value, comma, animator damp time, comma, time.delta time. Pop down here and say handle rotation, which will take as an argument move input and movement value. Now let's make those methods. Private float get movement value. Like we said, it's going to take an argument. That argument is a vector 2. We're going to say bool keyboard input equals keyboard.current does not equal null, and keyboard.current.wkey.isPressed, or, and now we're just going to go through all the WASDs of our options here, keyboard.current.akey.isPressed or keyboard.current.skey.isPressed, same thing for the D key. And then let's just clean this up so that it's a little more readable and not all on one really long line that we can't look at. We'll drop down and we will say if keyboard input return 1F. Basically, if you're pressing a keyboard button, just set the speed to 1. Now, if you're using a joystick, it's a little more complicated. Float analog value equals mathf.clamp01 move input.magnitude. If our analog value is less than our movement threshold, return 0F. Basically, if it's just really small, don't count it as the player trying to move, and then return the analog value. Next, let's make our handle rotation. So we're taking as an argument in this one vector 2 move input and a float movement value. We'll say if move input dot square magnitude is less than some very, very small fraction here, 0.0001F, or movement value is less than or equal to 0, then we're just going to return. We're going to assume no rotation is needed here. Vector 3 reference forward equals vector 3 dot forward. Vector 3 reference right equals vector 3 dot right. Dot right, right. Just one is perfectly fine. Now, if our camera transform is present, if camera transform does not equal null, then our reference forward is actually going to be our camera transform dot forward. And you guessed it, our reference right is going to be camera transform dot right. And we also need to say reference forward dot y equals 0F. Reference right dot y equals 0F. Then we're going to say reference forward dot normalize and reference right dot normalize. And that should handle all of that. And we're going to say vector 3 desired direction is equal to our reference forward times our move input dot y plus our reference right times our move input dot x. Desired direction dot y equals 0F. And now we can say if our desired direction dot square magnitude is less than our very, very small fraction, we return. Then we say float target angle equals mathf dot atan2 desired direction dot x and desired direction dot z. Then we'll say float current angle is equal to transform dot Euler angles dot y. Then we'll have another float called smoothed angle, which is equal to mathf dot smooth damp angle. And we'll pass in the current angle, target angle, we'll have a ref rotation velocity and rotation smooth time. Then we'll say transform.rotation equals quaternion.Euler 0F smoothed angle 0F. I mean, one more little thing in here, and this is our on animator move method. We're going to say transform.position plus equals animator.delta position. And then we're going to say transform.rotation times equals animator.delta rotation. Got to multiply by the rotations. Let's pop back into Unity, drag in these references. We've got our animator, we've got our camera transform. For our input references, this should already be in here. We're just going to grab the one they've already made. Now let's go into our animator, and you can see this movement needs to be exactly the same as that movement parameter. Let's hit play and see if it's working. Well, our player moves forward, that's good, but he doesn't turn left and right, and he's endlessly running away from our camera because our camera's not moving. That's not great. Let's fix that. Why is the rotation not working? Maybe it's because I didn't put the camera in there. So let's go to the Cinemachine, add a Cinemachine camera. I'm going to just drag this up next to the main camera. Let's open this up, and the tracking target needs to be the player. And then we can go to the position control and say follow. The rotation control, let's make that a hard look at. I'm going to make the follow offset just a little bit higher, and then let's hit play and see what happens. Okay, now we're running forward and the camera's moving with us, but we still can't move left and right. So what did I do wrong? It's got to be something in the code. And it was right here. We needed to multiply the target angle by mathf.rad2deg. We need that in there or it's not going to work. Now that we have it, voila. We can run around. We're running through walls just like we planned. Okay, yeah, we don't want that. There's no gravity right now, so we can just kind of walk off a cliff. Very exciting. But hey, we're moving around, and that's already looking pretty good. So in the next video, we will address running into walls, dealing with gravity, making sure we don't fall through the ground, all those kinds of things.